Have you ever used your GPS and just marveled at how it finds the fastest route in like 2 seconds flat? Or how an AI can look at a ridiculously complex puzzle and just solve it? Well, it's not magic, but it is incredibly clever. Today, we're going to pull back the curtain on one of AI's most powerful secret weapons, the heuristic search. And this is really the heart of the matter, isn't it? When an AI is staring down a problem with trillions upon trillions of possible answers, checking every single one, what we'd call a brute force approach, would literally take centuries. So how does it sift through all that noise to find the one perfect path, that single best answer so unbelievably fast? The secret is all about making a really, really smart guess.
Okay, so here's our game plan. First, we're going to break down the sheer scale of the search problem itself. Then, we'll introduce the hero of our story, the educated guess. After that, we'll get into the super important rules that this guess has to follow. We'll see how a better guess makes for a faster search. And finally, we'll look at how AI designers actually come up with these brilliant little shortcuts in the first place.
All right, first things first, we have to appreciate just how massive this challenge is. I want you to picture being dropped into the middle of a colossal, uncharted maze. If you wanted to find the exit by just trying every single path, one by one, well, you wouldn't just be slow, it's pretty much a guarantee you'd never get out. And that's the kind of problem AI faces constantly.
And it's not just mazes. Think about a delivery company planning a route with thousands of stops, or solving a Rubik's Cube, which has quintillions of possible states, or even a chess computer trying to find the best move. The number of possibilities, what we call the search space, is just astronomically huge. Searching blind is a complete non-starter. You need a guide. You desperately need a shortcut. And this is where the solution comes in. And it's just so elegant. Instead of fumbling around in the dark, we give the search algorithm a guide. It's like giving it a compass that always points it in the general direction of the exit. This guide, this educated guess, is the secret sauce. In the world of AI, we call it the heuristic function, which you'll often see written as h of n.
So, what does this huff n actually do? Well, it looks at where you are right now, your current state, or node n, and it spits out an estimate of how much further you have to go to reach the goal. Now, the most important word here is estimate. This is a guess. It's an informed guess, hopefully a very good one, but it is not a guarantee. It doesn't know the true exact cost. But a good guess is the difference between solving a problem in seconds and, well, never solving it at all.
Now here's where things get really interesting. See, you can't just use any old guess. If your goal is to find the absolute best solution, not just a solution, but the optimal one, then your guide, your heuristic, has to play by two very specific, very important rules. The first rule is called admissibility. And what this means is that your heuristic has to be an optimist, always. It can underestimate how far you have to go, that's totally fine, but it can never overestimate it. Let's go back to the GPS example. The straight line distance, as the crow flies, from you to your destination is a perfect admissible heuristic. Why? Because you know for a fact that any real road trip is going to be at least that long, probably longer with all the turns. It's an optimistic guess, but it's never unrealistically optimistic. Okay, rule number 2 is consistency. This one's a little more subtle, but it's just as critical. Basically, it means your estimates have to make logical sense as you move from one step to the next. The estimated cost from where you are now, let's call it point A, can't be more than the actual cost to get to your next door neighbor, point B, plus B's own estimated cost. It's like the triangle inequality in geometry. It makes sure that as you get closer to the goal, your estimated total cost never suddenly goes down. Things only get more realistic.
So, why are we so obsessed with these two rules? Well, here's the massive payoff. These rules aren't just suggestions. They are mathematical guarantees. When you use a powerful search algorithm like the famous A*, and you pair it with a heuristic that is both admissible and consistent, you are guaranteed to find the cheapest, the fastest, the absolute best solution every single time. It turns a guessing game into a certainty.
All right, so now we know the rules for what makes a heuristic work. But let's say we come up with two different heuristics, and they both follow the rules. How do we know which one is actually better? How do we measure the quality of a guess?
Well, for that, we use a really cool concept called dominance. It's pretty simple. If you have two admissible heuristics, let's call them H1 and H2, and H2's guess is always higher than or equal to H1's guess, then we say that H2 dominates H1. A more dominant heuristic is just a more informed, more accurate guess. It's still an optimist, remember? But it's a much more realistic optimist. And this is where you see the real magic happen. The more dominant your heuristic is, the better it is at pruning the search tree. It tells the algorithm to ignore bad paths much earlier in the process. That means the algorithm has to explore way fewer dead ends and wrong turns. And that translates directly into a massive, sometimes mind-blowing, speed up in finding the solution.
And this brings us to the theoretical ideal, the holy grail of heuristics. A perfect heuristic would be so accurate that it would guide the algorithm straight to the goal without exploring a single wrong turn, not one. In technical terms, we'd say this gives it an effective branching factor, or a B star, of 1. It's a perfectly straight line from start to finish.
This all sounds fantastic, right? But it begs the question, where do these amazing functions even come from? Are AI developers just sitting in a dark room dreaming them up? Well, not exactly. The most common method for creating a truly brilliant heuristic is actually surprisingly systematic and clever.
Here's the trick. You take your original, really hard problem, and you just make it easier. You relax the rules. You remove some of the constraints that make it so difficult. The cost of solving this new, simpler, relaxed version of the problem automatically becomes a perfectly admissible heuristic for the real, harder problem. It's a beautiful, elegant idea.
Let's make this real with the classic 8 puzzle. So one possible heuristic, we'll call it H1, is to just count the number of tiles that are in the wrong spot. The rule we've relaxed here is that a tile can basically teleport instantly to its correct position. Now, a better heuristic, H2, is what's called the Manhattan distance. For each tile, you count how many squares up, down, left, or right it is from its goal, and you add all those up. Here, the rule we've relaxed is that tiles can move right through each other. And because H2's estimate is always going to be higher than or equal to H1's, the Manhattan distance dominates the misplaced tile count. It's a much more powerful guide.
And relaxing problems isn't the only trick in the book. There are other really cool techniques. For some problems, you can pre-calculate the perfect solution for small parts of the puzzle and store them in what's called a pattern database. Or, and this is where things get really futuristic, you can use machine learning. You have an AI solve thousands and thousands of practice problems and let it learn its own heuristic from experience.
So really, it all boils down to this clear 4-step recipe for engineering a fantastic heuristic. 1. Define your problem with absolute precision. 2. Relax its rules to create a simpler version. 3. Double-check to make sure your solution to the simple problem is always optimistic, that it's admissible. And 4. Try to make that guess as high, as close to the real cost as you possibly can without breaking that optimism rule.
And that really brings us to the single most important takeaway from all of this. The heuristic function isn't just some minor tweak or a small optimization, it is everything. The speed, the power, the very possibility of solving one of these massive search problems comes down almost entirely to the quality of that educated guess.
Which leaves us with a final and pretty fascinating question to think about. As we start giving AI even bigger and more complex problems to solve, things like designing new life-saving drugs or optimizing our planet's entire supply chain, the art and the science of inventing new, more creative, more powerful heuristics is going to be the very center of the next great wave of innovation. It seems the future belongs to whoever can make the best guesses.